Welcome back to Mrs. Bisson's virtual classroom. Today we will be learning how to solve one-step equation word problems. We've already been working with addition, subtraction, and multiplication and division word or actual equations, but today we are going to learn how to solve word problems. For this lesson, you will need a sharpened pencil with an eraser, a calculator, your guided notes sheet, and you'll need to follow along and fill in the spaces as prompted in the video, and of course your headphones. If you're missing any of these supplies, please pause the video and retrieve them and resume the video when you get back. So to review, what are some of the key words in math problems that indicate the operation? Well, we have an addition. We know that if it says plus, the sum, total, added to, in all, combined, those are indications that we may be working with an addition problem. In subtraction, we have minus, difference, change, less than, decrease, taken from. Those are some examples of word problems that could potentially be subtraction problems. Multiplication, we have product of the times, of, twice, or triple. That could potentially be a multiplication problem. And in division, we have if something goes into something else. Per is a big clue that it's a division problem. Half of, evenly, or divided by. These are just some of the keywords that could show up in math problems. Of course, there's a whole list of problems I know that we've been through before. We've reviewed that, and you reviewed that with Miss D actually before your winter break that you had. So how do you solve a one-step word problem? There's the familiar cat again. You use cubes, and I know we've been working with cubes in every word problem that we've worked with so far, and cubes involve circling the key numbers, underlining the question, boxing in any of the action words, evaluating, and of course solving, and we can't forget checking. We always need to check our answer. So let's go through an addition word problem. Now in your activities and your exam, it will say solve this addition word problem. So you will be given the operation that the problem is using. So in here we have a problem. It says Lisa is cooking muffins. The recipe calls for 7 cups of sugar, and she's already put in 2 cups. How many more cups does she need to put in? So the first thing that we're going to do, of course, is circle our numbers. And we know she's cooking muffins. The recipe calls, okay, so how many more? That gives us a clue that we're working with an addition problem here, and here is our question. So how would we set this up? Well, we know that the recipe calls for 7 cups of sugar, and we could say the recipe calls for 7 total cups of sugar. So we know this is our total, and we know then that whatever it is, it will equal 7. Okay, so we know that it will be x plus something because we've already been told that this is an addition problem. So it actually turns out to be x plus what? Well, we already know we use 7, that's the total, and we know here that Lisa put in 2 cups. So we have x plus 2. Obviously this is a very simple problem. Go ahead and solve this. I will solve this here as well. We know that the operation that we're working with is addition, plus 2, and in order to undo that, to get rid of that 2 and get the variable by itself, we need to subtract 2, of course, from both sides. So minus 2 here, minus 2 here. I noticed that a number of you like to put the line here to organize your problem. So then you have x is equal to 5. Of course, we need to check our answer, so I'm going to go ahead and do that over here. X plus 2, and you should have space underneath to do that. I don't here, obviously, because I'm limited with space, but make sure that you do your check under your problem. And I got the answer of 5 for x. So 5 plus 2 equals 7. Oops, I put 7 there. Got a little excited. Okay, so 5 plus 2 equals 7. and then we know 7 is equal to 7, and that is correct, so we know that we are right. These problems are not difficult. I know that you'll be able to do this. Okay, let's go ahead and look at a subtraction problem. Julie baked cookies. Unfortunately, her brother snuck in and ate 7 of them, and she only had 19 cookies left. How many cookies did Julie make? Well, think about it. What if this happened to you? How would you figure that out? How would you figure out how many cookies were originally there? Okay, so we're going to circle our numbers. We know our question is how many cookies did Julie make? So he ate 7 of them. We know that this is a subtraction problem because he ate them. So that means that they disappeared into her brother's stomach. So we know that she only had 19 cookies left. And we know it's a subtraction problem. So we know that it's going to be equals 19. We don't know how many cookies she made, but we do know that 7 of them were subtracted from the number that she made. And there is our subtraction problem. All of your problems will follow this general process here. So I'm making my do and undo chart. And I know that the operation that I'm working with is subtraction. And so 7 is being subtracted from x. In order to get x by itself, we're going to add 7 to both sides. And I know that you are masters at this, and you certainly don't need me to walk you through this process. Go ahead and pause the video and solve it on your own. And you should have gotten x equals 26. Make sure you have your check on there. You should have, of course, 26 minus 7 equals 19. And then you would, of course, have 19 equals 19. If you did not get that, please raise your hand and I will come and assist you. All right, so the next problem, how many bags of chips can you buy for $15 if each bag costs $3 each? So I'm going to circle my numbers here. Okay, they're asking how many bags of chips can you buy? And then here, this each bag gives us a clue as to what kind of an operation we're working with here. And it, like I said before, it will indicate on your test, this is a multiplication word problem. So this is multiplication. So how would you set that up? Well, you know that you have $15. You know that each bag costs $3. So here, all you're going to do is, you know what your total is. You know your total is 15. And I can even write total there. And you know it's 3 each, but you don't know how many bags. So your unknown variable is x. 3x equals 15. So go ahead and solve that and let me know what you get, or actually write down what you get. Don't forget to do your do and undo chart. And you know that x is being multiplied by 3. So you're going to divide by 3, and I am going through this very quickly because I know that you already know how to do this because you are masters at this for sure. Okay, so you know that that cancels that out because of the zero property there, so that divides there, and then you have to do what you do on one side, you have to do on the other. You should get x equals 5. In order to check that, we take 3x equals 15, and then we take 3 times 5 equals 15. Notice I did not use an x, I actually just used the dot there, and I should have gotten 15 equals 15, and that is correct. So here we have a division word problem, and we know that LeBron, Kyrie, and Mo went out to dinner and split the bill evenly. They each paid $41. How much was the total bill? So from looking at that, we can tell that we have $41, and we know how much was the total bill is the question. And there's a really important word in here that we need to use that we can go ahead and cube in that gives us an indication that this is in fact division, and that's the word evenly, and that was in our list that we saw at the beginning of the lesson. And we are missing a number here, but we're really not. It's in the words. We know LeBron, Kyrie, and Mo went out to dinner, and that's actually 3 people, so that is a number, even though it's in word form, because we know that there were 3 people who went out to dinner. So how would we set this up? Well, we know that they each paid $41. So that will be what it is equal to. Now, we don't know how much the bill is, but we know it was split by 3 people. So we know that the 3 is the denominator there, and the numerator would then, of course, be our variable. So x divided by 3 equals 41, and that is our division word problem. I know you know how to solve this from here. Don't forget to do your do and undo chart. You know that x is being divided by 3. Therefore, the inverse operation of division is multiplication. So it would be, both sides would be multiplied by 3. You multiply both sides by 3. That cancels that out. You should have x equals, and don't forget your unit, it is in dollars, so don't forget to put that there, 123. So in order to check this, then you would say x over 3 equals 41. You would put 123 divided by 3 equals 41. Go ahead and check that in your calculator and resume the video. 41 is equal to 41, and you know that that is in fact correct and that you did a good job solving this. So these are very easy questions. Like I said before, don't let all the words scare you. These are things that you've done before. I know you can do it, and the type of operation that you will be using will already be defined in the problem for you, so you don't have to worry about trying to figure that out. Although I do want you to identify those words like evenly and less than and things like that, because as you go through math this year, next year, and even in high school, you'll definitely be working with word problems. So any questions, please raise your hand. I will come assist you. But now it is time to go ahead and get started practicing. Great job, guys.